cycle assessment of chicken manure for energy production. This presentation will discuss the effects of generation of electricity from two biofuels, coal-fired rapeseed oil and the combustion of chicken manure. The comparison between these two biofuels will be analyzed through life cycle assessment and its technical framework, which includes goal and scope definition, inventory analysis, impact assessment and interpretation. The goal to analyze and compare these biofuels and assess which emissions and ultimately which process contributes the most to the global warming effect. The functional unit for this case is 1 kWh of electric energy. The scope for the analysis is based on a chain of rapeseed from the transportation of the matter. This is the same with chicken manure. It is assumed that it is given, so the analysis does not take into account any process before the chicken manure. Inventory analysis. In the following diagrams, we will see the different processes that each biofuel went through in order to produce electricity. It is the same to mention that some of the processes from the rapeseed chain were taken into account in order to build the process of generation of electricity from chicken manure. While comparing the two outputs of electricity at consumer from coal-fired rapeseed oil and from chicken manure in Northern Europe, we use some extensions and products from the chain of rapeseed oil. For instance, we use the same lorry for the process of transportation of the chicken manure as the one used for transportation of raw rapeseed. This way, LCA can make a better comparison of the processes, using the same kind of transportation. During the transportation process, we had to make an allocation of two inputs, the chicken manure and the transport of lorry. For this allocation, we use partitioning in order to continue with the next process, which is storage manure. During the storage of 1 ton of wet manure, 3.1 kg methane and 0.014 kg dinitrogen oxide is emitted. The storage of chicken manure results in emissions, called extension out in the LCA, of the nitrogen monoxide and methane in the air. For the drying of chicken manure, we use 314 megajoule of heat from natural gas in an industrial furnace. During the process of drying, 1 kilogram of methane is emitted. The next process is the combustion of the dried chicken manure, which was done with lean burn from natural gas to get energy from the chicken manure. A study on the improving performances of lean burn cogeneration biogas engine equipped with combustion pre-chambers shows that lean burn is the most effective way of combustion. The combustion of dried chicken manure resulted in emission of biogenic carbon dioxide. This emission was chosen because it happens through combustion of material produced by living organisms. After the process of combustion, energy combusted chicken manure went into the final process of transportation and transport of electric energy, which outcome is finally the electricity at consumer. Impact assessment and interpretation. The first table shows the comparison of output products made by producing electricity from rapeseed and chicken manure. Producing electricity by using chicken manure impacts the global warming effect less than using rapeseed. The second table shows the distribution of the output products considered to contribute to global warming. The third table shows the processes through contributing to the emissions of carbon dioxide. The carbon dioxide emissions of rapeseed are 3.5 times more than that of chicken manure. Table 4 shows processes contributing to the emissions of dinitrogen monoxide. The dinitrogen monoxide emissions of rapeseed are 53.6 times more than that of chicken manure. Table 5 shows processes contributing to the emissions of methane. The methane emissions of chicken manure are 22.1 times more than that of rapeseed. Conclusions. The chicken manure is biogenic waste. As a result, the carbon dioxide that is emitted is also considered biogenic carbon dioxide. Biogenic carbon dioxide is not considered one of the emissions responsible for global warming. Therefore, the carbon emissions of chicken manure are much lower than that of rapeseed. The nitrogen monoxide emissions are much higher for rapeseed than for chicken manure. And fertilizers are used for the production of rapeseed and is the biggest contributor for dinitrogen monoxide emissions. The process is completely absent in the chain of chicken manure, and fertilizer production doesn't just play a role in creating dinitrogen monoxide, but it's also a big contributor to carbon dioxide and methane emissions. However, chicken manure emits a large amount of methane when dried and combusted, which isn't true for rapeseed. This leads to a bigger impact. Recommendations. The LCA analysis is only on the environmental impact. A recommendation would be to include an economic part. Another recommendation would be to calculate the input of 1000 kg of rapeseed in the dried process in order to know how much it goes to emissions.